Hello guys, this video is in continuation of your earlier class. The last class we were discussing about bank of single phase transformers, wherein we came across the major drawback of using single three phase transformers, that is, if one phases become faulty, then we have to change the whole transformer. That is, we have to remove that particular transformer from the service for the repair work. So this doesn't happen with respect to using bank of three single phase transformers. Even your one transformer get failed, then other two transformers can be connected in the delta connection so that three phase supply can be enjoyed with the reduced capacity or reduced kV of the transformer. Let us see the advantages of having three single phase transformers. Like I told you, it is used in mines, as the mines are very shorter in size, or even people can hardly go inside there. So in that case you can't take single three phase transformer there. So in that case you can go with the three single phase transformers for the underground transport, and also it becomes cheaper to carry such three single phase transformers. So here advantages of having bank of three single phase transformers can be summarized as follows. So even for unbalanced load, you can connect two different kVA rating transformers so that it can supply the unbalanced load. It is possible. Usually what happens, if I want to connect the uh, single phase transformers, that is bank of single phase transformers, so in that case we need to have all the transformers of same rating. But if you want to connect two transformers, means I can connect two different kVA rating transformers so that unbalanced load can be supplied. That is the advantage, but it is not true for your single three phase transformers. Again, like I told you, when one of the transformer is out of service, say one of the transformer is faulty, then you can use two single phase transformers in the form of VV connection. VV connection means what? Open delta connection. Okay, delta 1 connection is not there, right? So it is called as VV connection at a reduced capacity, means kVA rating will be reduced. So in a bank of three single phase transformers, if one single phase transformer is kept as spare, so rather than keeping whole three phase unit, so which is expensive. So if you have one more spare with you, so if something goes wrong, then you can replace that particular transformer. So one more thing is what, you can conveniently transport the single phase transformer rather than three phase transformer. This is what the one more advantage of having bank of single phase transformers. Now let us move to the various three phase transformer connections. We have at the first star star connection, second delta delta connection, third star delta, fourth delta star, fifth one is open V connection. I told you, if you want three phase connection out of two single phase transformer, then you're going to do V connection or open delta connection. The other one is Scott connection. This is connection which you are using to convert three phase into two phase. Okay, we shall learn one by one. And the first we have star star connection. See, first thing what you need to remember in the star star connection here is the phase current as well as line current are both same. Okay, the phase current as well as the line current are both same here in both the star star connection, whereas phase voltage and line voltage are not same. Okay, phase voltage and line voltage are not same. Phase voltage will be 1 by root 3 times that of line voltage. Let us see what phase mean, what line means, what is phase current, line current, everything. So here you can see this is the star connection in the primary side and this is the star connection in the secondary side. Phase voltage in sense what? The voltage measure between any one line as well as neutral. Myself clear? The voltage measure between any one line and neutral is called as what? Phase voltage. It may be V or say this is neutral here, which you all know, neutral it is extended over here. So if I'm going to measure the voltage between V, that is R and N, means it will be phase voltage. If I'm going to measure the voltage between Y and N, means it will be a phase voltage. If I'm going to measure voltage between B and N, means it will be a phase voltage, VBN. So what is line voltage then? The voltage measure between any two lines. The voltage measure between any two lines. It may be between R and Y, it may be Y and B, or it may be between R and B. All are what your line voltages. And I told you phase voltage is characterized by what? Formula 1 by root 3 times that of line voltage. VL can be between R and Y, it can be between Y and B, or it can be in between R and B. Okay, now coming to the phase current and line current, the current which flows. So this is basically a line current here, IR whatever shown. It flows till here same. Yes, this is the phase, first phase, second phase, third phase. So anyhow the current is not dividing anywhere else. So whatever line current is there, it will be same in this phase also. So phase current and line current is same. So it is true for the secondary side as well. Whatever I told with respect to primary side, it is true with respect to the secondary side. They have shown here suffixes, small letters, just to show that voltages are not same when compared to primary as well as secondary. That's it. Okay. So this is the phasor diagram representation of primary as well as secondary. You can see R is the reference phasor, Y is lagging behind R by 120 degree, whereas B is leading VR by 120 degree. Yes, all three phasors are what? Having phase angle of 120 degree electrically apart. Similarly, your secondary side is also star connection. Here also we have three phasors R, Y, B, and here also the phase angle is 120 degree apart. So let's see how actually the connections are made. If you are using a bank of 3 single phase transformer, you can see all the ends of one of the terminals of all 3 phases are shorted together, calling it as neutral, and remaining ends are given with the supply RYB. Similarly, we are doing with respect to the secondary side. We are shorting one ends, we are calling it as N, whereas the remaining terminals are called as R, Y, B. Okay, output which you are going to get. Here the resistor is shown just to show that there is a load, resistive load which is connected between R as well as N, that is single phase is connected. Single phase load is connected in the secondary side just for representation sake. Like I already told, V phase equal to VL by root 3. If I want to with precisely with phase 1 means we can add suffix 1 here. So VL1 by root 3. So we have a transformer ratio formula. Already I told that K is equal to what? V2 by V1. Precisely it is V phase 2 by V phase 1. If I want to write V phase 2 in terms of line voltage from the primary winding, then the formula will be what? V phase 2 equal to K times that of VL1 by root 3. Okay, again I'm going to repeat. If I want to write a phase voltage of secondary side in terms of line voltage of primary side, then formula will be V phase 2 equal to K times of VL1 by root 3. Otherwise, with the same phase, with the same primary winding, if you want to write means it will be V phase 1 equal to VL1 by root 3. Okay, 2 represents secondary side, 1 represents the primary side. Done. Okay. If you want to write in terms of line voltage of secondary side, then the formula will be obviously VL2 equal to root 3 times of V phase 2, right? You can replace V phase 2 by this formula, K times of VL1 by root 3, K times of VL1 by root 3, any of they are written VL2, they have made mistake here. So it should be VL1, so root 3 gets cancelled, so it is K times by VL1. So VL2 is equal to K times of VL1. Okay, that's why what it is written here, the line voltage on the secondary side, 2 means secondary side, is K times, that is K multiplied the voltage across the primary side in terms of line, that is line voltage on the primary side. Okay, so finally let us get into the advantages. So due to star connection we get the two different voltages. One is reduced voltage, that is V phase voltage. One is the line voltage, that is line to line voltage. So you can have two desired voltages. Since the number of turns are less because of reduced voltage, so there is also stress is less on the insulation. That makes economical for small high voltage purposes. And like I told you, star connection, the phase current and the line current are same, hence the windings can carry high currents. So cross section of windings are high as it carries high currents. Thus our transformer will be mechanically strong, so that the windings can bear high loads or as well as heavy loads, and also it can bear short circuit conditions to some extent. Again, there is no any phase shift between primary as well as secondary side, like we saw. They were both in the star, so there is no any phase shift. As we have neutral here, so it is suitable for single phase purpose, as well as it is suitable for 3-phase 4-wire system. Okay, both. One more disadvantage of this star-star connection is, even after the availability of the neutral point, that is even primary is earth, sometimes what happens, due to unbalance in nature, the neutral will carry the zero sequence current, and that too it is a third harmonic, which may even reflect on the secondary side of the transformer side. So this causes the distortion in the phase voltages if any load connected there. Okay. So due to these disadvantages, such connection is rarely used in practice, and it is only used for what? Small high voltage transformers. Anywhere small high voltage application is required, then we are using what? Star-star connection. Now come to the delta-delta connection. As the name itself indicating, in the delta manner, I am going to connect the our transformer in delta fashion with respect to both primary as well as secondary. Here again, the thing which you need to remember here is the phase voltage as well as the line voltage are same. In star-star it was different, but in delta-delta it is same. Either it is primary or secondary, phase voltage and line voltage are both same. And what about current then? Yes, currents are different. That is, phase current is different, line current is different. Okay. Now coming to the voltage part. The line voltage is nothing but what? The voltage measured between any two lines, like I told in the earlier connection. So the voltage measured between R and Y will give you line voltage. The voltage measured between Y and B will give you line voltage, or the voltage measured between R and B will give you line voltage. Okay, R, this is also R, because since the potential is same, this is also Y, until here it is B. Okay, from this point to this point. Now coming to the currents. Current, you can see IR is flowing. IR is nothing but what? Line current. Since it is flowing in the line, so I'm going to call it as line. Okay, but when it reaches here, the current is going to split up, right? Current is going to divide here. So whenever the division occurs, remember current will be not same. So when it gets divided, it flows in this phase as well as in this phase. Yes. So the phase current, the current which flows in the phase, in this winding, is called as phase current. The current which flows in the line is called as line current. So current which flowing in the winding is called as phase current, and the phase current and line current are not same. Why? Because it is getting splitted up here. It was not in case of our star-star connection. There is no any such division was seen. Right? So here phase current is characterized by the formula 1 by root 3 times of the line current. Just like we were having formula for phase voltage in a star-star connection, here also we have same. The phase current is characterized by the formula 1 by root 3 times that of line current. It is same with respect to the secondary side. Again, phase voltage is also same, measure between any two voltage, as there is no any neutral. Like I told you already, definition that voltage measure between phase and neutral is called as phase voltage, but here there is no neutral at all, right? So here we have got no options here. So the voltage measured between R and Y will give a line voltage as well as the phase voltage. So both are same. So this is what we have, the delta connection. And coming to the phasor diagram, you can see we can write a phasor diagram like this: VRY, VYB and VBR, depending upon the directions of this VRY. You not to bother much about this. In this again you're going to learn this more in your incoming semesters there. Just remember this: VRY, VYB as well as VBR. Similarly, VRY, VYB, VBR. Okay. And again this connection provides economical for a large low voltage transformers, as it number of turns are more here, because the voltage is same, that is phase voltage, line voltage same, number of turns are more, but it carries high voltage, but it carries less current. It is not suitable for carrying high current. And again here also there is no any phase shift seen between respect to primary as well as secondary. Okay. So this is how we are going to use bank of 3 single phase transformers for delta sake. Like I told you, line current, line voltage and phase voltage are both same. Again the formula remains same: K is equal to V phase 2 by V phase 1. So V phase 2 is equal to K in times of V phase. Since I told you primary and secondary are both in delta connection, again we know that primary voltage as well as secondary voltage, phase voltage and line voltage are both same. That's why the reason VL2 is equal to V phase 2 and V phase 2 equal to K times of V phase 1, or it may be VL1, because since both are same itself. Okay. Now coming to the advantages.